Okay, so we're looking at solving number 5, which again is going to be very interesting because x is there twice. I divide it with my just equal sign, make sure I balance the equation, and I want to isolate the rational exponent expression x minus 3. So I need to get rid of the plus 2. When I do that, I'm left with x plus 3 to the 1/2 power is equal to x minus 3. And now I'm going to get rid of that half power with a square power, or the reciprocal of 1/2, which is just second power. So I give second power to both sides of the equal sign. And on the left side, the exponents just cancel out, and x plus 3 is the result, which is very nice. However, x minus 3 squared is actually meaning x minus 3 times x minus 3. It means that that's happening twice. So we need to multiply these binomials. And I use FOIL, first, outside, inside, last. And I get x squared minus 3x plus 9. Combining like terms, I get x squared minus 6x plus 9. So now I have a quadratic expression that needs to be simplified and solved. And there's going to be 2 answers, and we're going to find those with either factoring or the quadratic formula. But recall, to do that, we're going to need to make one side equal to 0. So I'm going to make the x plus 3 equal to 0 by going minus x minus 3 and combining the like terms. Now I have 0 is equal to x squared minus 7x plus 6. And this can be factored. I make my t-chart, looking for numbers that multiply to 6 and add to negative 7. It's negative 6 times negative 1. And then I will factor x squared minus 1x minus 6x plus 6. Drawing the fence, taking out the GCF, x times x minus 1 minus 6 times x minus 1. And then getting the result, x minus 6 times x minus 1. Still equal to 0. Oh man, we're taking up a lot of space on this problem. Then we use the zero product property, setting each of those respectively to 0 to find our answers. And so I know that x minus 6, it would be 6 minus 6. So we've got x is equal to 6, or x is equal to 1. Now this is the type of problem that's probably going to have extraneous solutions because we have 2 answers. And let's just go ahead and plug them both in and see if they actually work. So I'm erasing my work here, and I'm going to plug in back to the original expression. So I'm plugging in 6 plus 3 to the half power plus 2 is equal to 6 minus 1. So 6 plus 3 is 9. 9 to the half power is 3. Plus 2 is equal to 5. That checks out. So x equals 6 for sure works. Cool. What about 1? So I can pretty easily do 1 plus 3. 1 plus 3 is 4 to the half power plus 2 is equal to 1 minus 1. So this is saying the square root of 4, 2 plus 2 is equal to 0. And unfortunately, that is not true. So that means that x equal to 1 is the extraneous solution. Wonderful. Let's take a look at number 6. So on number 6, again, we have x in this expression twice. And that means that we are likely to have to do a lot of work. So I'm going to isolate just one of those expressions. And so I'm going to isolate the x plus 8 first by doing it's minus now, by doing plus rad x plus 35 on both sides of the equal sign. All right, so on number 6, I want to isolate the radical expressions, but there are 2. So I'm going to isolate one at a time. So I'm going to draw my equal line, and I'm going to isolate the x plus 8 first. So I'm going to get rid of the whole expression rad x plus 35 with plus rad x plus 35 plus rad x plus 35. So that radical expression can't change. It's inside the radical, And so now I'm left with rad x plus 8 is equal to, and I'm going to write it like this, rad x plus 35, and then it's minus 3. So to make sure that that minus 3 doesn't end up inside the radical by accident, because it does not just jump into a radical. And just like what we did in number 5, I'm going to take the square power on both sides. Square power cancels out square root, and I'm left with x plus 8. And then on this side, I put parentheses on it and I square it. And again, that means that I have to multiply it using FOIL. So I'm going to do that work over here. Rad x plus 35 minus 3 times rad x plus 35 minus 3. Okay, first, multiplying those together, that's going to cancel out the radical. That's going to be x plus 35 because it was square root of that squared. So they canceled out. And I don't want those symbols there. So then I'm going to do over here minus 3. So that 3 is going to go on the outside. So it's going to be minus 3 rad x plus 35. Then I'm going to do the inside, and I get the same result. The 3 is on the outside, and then x plus 35. And then finally I do negative 3 times negative 3, which is positive 9. So I'm going to combine these two. They are like terms, and that they can be added together because they have the same value inside the radical, the matching radicand. So I get negative 6 rad x plus 35. The 9 and the 35 can be added together to make x plus 44 minus 6 rad 30 at okay. So our end result is x plus 44 minus 6 rad x plus 35, and this was on this side. So I'm going to write it over here, x plus 44 minus 6 times rad x plus 35. Okay, cool. Wow, that was a lot of work. So now I'm again going to start the process over of trying to isolate this radical. So I'm going to get rid of the x, I'm going to get rid of the 44, and then I'll have to get rid of that multiplying by negative 6. So when I subtract x, cool, the x's cancel. When I subtract the 44, I get negative 36 is equal to negative 6 rad x plus 35. That's negative 6 times the radical, so now I divide both sides by negative 6, and I get positive 6 is equal to rad x plus 35. Finally, the radical is isolated, and I can get rid of square root with square power, and I get 36, oops, and I get 36 is equal to x plus 35. Subtracting 35, I get x is equal to 1. So that was a huge amount of work. We had to multiply with FOIL using a radical expression as the x value. So it was something very interesting. And so I needed a lot of space to do my work on this problem, and then here the end result was 1. Let's plug it in and see how that works out. So 1 plus 8 is 9. The square root of 9, which is 3, minus 1 plus 35 is 36. That's minus 6 is equal to negative 3. Yes, it does work. Wonderful. So we're so glad that all the work ended up giving us the correct answer. Okay, number 7. On number 7, we notice that the exponent is not 1/2, it's not square root, it's 2/3. So this is where we're going to use the reciprocal power. The reciprocal of 2/3 is 3/2. So I take the 3/2 power on both sides. And then on the left-hand side, it just cancels out, and I'm left with x plus 5. But if I have 4 to the 3/2 power, I want to use my exponent rules to simplify that. Or I can write it in radical form. I prefer using exponent rules. So my side thinking is saying, okay, 4 is the same as 2 squared. So I've got 2 squared to the 3/2 power. Now I have a power to a power, so I multiply the exponents, and I've got 2 to the 6/2 power, which reduces to 2 to the 3rd power. 2 to the 3rd power is the number 8. So I write 8 is equal to x plus 5, subtracting 5. I get the value 3 is equal, x is equal to 3. Wonderful. So now how can we find x and y intercepts of radical functions? Let's take a look.